Hi guys, in the last lesson we have seen the product constancy table, and we have seen the percentage implication of the product or the percentage structure of the product constancy table. But there's an interesting alternate view to the product constancy table which I want you to know first. And this view is that if you look at those pairs that we talked about last time, if you remember, we have talked about that if x increases, y decreases, and you're talking about product change, x increases, y decreases. If x is increasing by 25%, y is decreasing by 20%. There's a fractional view of looking at this table also. And that fractional view, if you look at the pairs, x in this case was increasing by 1/4, due to which y was decreasing by 1/5 to keep the product x into y as constant. If you look at the other pairs, 20%, 16.66, x was increasing by 1/5, y decreases by 1/6. X increases by 1/6, 16.66, y decreases by 1/7, 14.28. X increases by 1/7, 14.28, y decreases by 1/8, 12.5. X increases by 1/8, y decreases by 1/9, 12.5, 11.11. X increases by 1/9, y decreases by 1/10, 11.11, offset by 10%. X increases by 1/10, 10%, y decreases by 1/11, 9.09%. X increases by 1/11, 9.09%, y decreases by 1/12. So the generic form of this table is that if x is increasing by 1 by a, y will drop by 1 by a plus 1. But the interesting thing to note now, why do you need to know these structures in fractions when you already know them in percentages? The reason for that is in percentages, the number of ratios you can remember, the number of structures or the number of pairs you can actually remember will be limited. You can't remember 37.5%, for instance. How much will it go down, right? But in this situation, once you know this relationship, I give you any non-standard value, 1/26 is the growth, you know that 1/27 has to be the drop, right? So this takes care, this is more versatile. This is more versatile than the product, than the percentage change, view of the product constancy table. So you are free to use any numbers here, any ratios. 1/37, I can't expect you to memorize 1/37 increases, 1/38 decrease. It can't be memorized by anyone, right? At least in percentage terms, it's very difficult to memorize this. But in ratios, you get much more freer to handle any values. And the best part of this is that this is not only 1 by a and 1 by a plus 1. If you have a situation where you are increasing x by 3 by 14, then y would decrease by 3 by 17. X increases by 3 by 14, y decreases by 3 by 17. So it is not just 1 by a and 1 by a plus 1. It is x by a and increase in one component, to x by a plus x decrease in another component. So if this is increasing by 5 by 23 and the product is constant, the other component should drop by 5 by 28, and so on, right? So this is the ratio implication of the product change graphic, the percentage change graphics, product constancy table. So this is the ratio implication or the fraction implication, and you should know this implication because, as I said, it frees you from a lot of undesired calculations, which you would have to do if you are only dependent on percentages for these questions. So for example, if I tell you that a man traveling over a certain distance, a man going from Ahmedabad to Surat, goes at a certain speed and a certain time to cover the distance. If he increases his speed by 3 by 23, what will be the reduction of his speed as a fraction? So you know that it will reduce by 3 by 26 in terms of the time. If speed is going up by 3 by 23, time will come down by 3 by 26. And suppose I frame a question on this. A man is going at a certain speed and takes 260 minutes to reach his destination. A man is going at a certain speed and it takes 260 minutes to reach his destination. If he increases his speed by 3 by 23, how much time will it take? How much time will it take to cover the journey now? How much time will it take to cover the journey in this case? So the change in the solution is this, or the simple single step structure of solution is this, that the speed is going up by 3 by 23. The time will come down by 3 by 26. And since the original time is 260, if you bring it down by 3 by 26, you are bringing it down essentially by 3 by 26 of 260, which means that the time will drop by 30 minutes. And if you are taking 260 minutes to start with, you will now take 230 minutes to cover the same journey. So as you can see, on a percentage structure, going up by 3 by 23, you will never be able to handle this because you can't be expected to remember those numbers. So ratios sets you free. It sets you free from only standard structures and standard values. You can handle anything, and of course you can also handle the standard structures and standard values. So you know that if it's going up by 1 by 4, the other component of the product has to come by 5, have to come down by 1 by 5 in a product constancy situation. So internalize both these aspects of the product constancy table. So the product constancy table, the percentage pairs, as well as the logic of 1 by A leading to 1 by A plus 1, increase decrease, and x by A increase leading to x by A plus 1, A plus x decrease. So we'll see more implications of this, of the PCG based percentage product constancy table in the next lesson. So I'll see you then. Bye for now.